Let's look at a pipe that goes from one area to another and through a height change and has a pressure acting on it. So we'll have an A1 and an A2. I have lots of labels here. We'll have a P1 pressure applied to the fluid down here. And if you think about it, if you want to push a fluid, you're going to have to apply a force on the area. So think about that, a plunger for a syringe or something like that. This will be a P2, so maybe this is open to the atmosphere, and when you turn on the faucet, the utility company is applying a pressure to one end of the pipe, and when you open up the faucet, the air out here is applying a pressure. It's not very big, and it's not going to, the pressure that the utility is applying is much, much greater, so the water comes out, and that's, you fill up your glass of water, or fill up the bathtub, or take a shower, but there is a pressure acting against it here. Now, if we look at a little piece of this fluid here, as it's going to travel, it's going to be moving, so it's going to have a velocity here. We'll call that V1, and it'll have a velocity up here. This will be V2. What's going to happen to the velocity up here at the top? Well, we've decreased the area, so it actually could get faster up there, right? Now let's go back to an old school equation. What is work? Force times distance, right? Okay. What's pressure? Force per area, right? So that means that the force is equal to pressure times area. Okay, so let's make a substitution. Then the work done by the pressure would be PA times D. What's area times distance? Area times distance. It's a volume. So the work done by the pressure would be P times truly our change in volume, but we'll just say that our volume is a certain amount that we're changing it by. So the work done is P times V. Now this pressure is applying a force. Is it a conservative or non-conservative force? It is non-conservative because it's not weight and it's not the electric force and it isn't our spring force. Do you remember the work done by a non-conservative force is equal to delta K plus delta U? Now we've got two pressures, so the work done, the total work done by our non-conservative pressure would be P1 times V plus a negative P2 times V, because pressure 2 at the top of the pipe up here was pointing to the left and it has a direction. So that would give us the total work done by the non-conservative pressure force of science. So P1V minus P2V will equal 1/2 mv squared minus 1/2 mv. I'm going to call this 2 and 1 since I've been using 1 and 2, okay? And then plus mg y2 minus mg y1. Do we use m mass for fluids? No. What do we measure fluids in? Volume. And how is volume related to mass? Through the density. So let's make a substitution. So now we made our substitution for the density times volume. What can we do? Looks like I can divide by volume on both sides, right? So let's cancel that out.